Hey everyone, welcome back. We're here at AWS reInvent in our suite up at the Wynn, continuing our coverage of this year's event. This gentleman to my right, I think the last time I saw him was at reInvent. I don't even think it was last year, Evan. I think it was the year before.
Yeah.
What a great, but he's a wealth of information, and you know the 6 degrees of separation in tech. There's 3 degrees of separation with this guy. Everyone I know knows Evan Kaplan.
Oh, geez. You run in some bad circles.
Yeah, I guess that's maybe
right.
what it means.
All right.
Evan, of course, is the longtime CEO of InfluxDB. If you don't know InfluxDB, shame on you, but we'll tell you about him in a second. Evan, it's good to see you, first of all, man.
Nice, Alan. Thanks for having me.
A pleasure. You know what? Let's start with InfluxDB. Look, I'm going to guess 85% of our audience may even be using Influx at some point, if not now.
Some high percentage, yeah. Yep.
Well, it's, our people are your people. They're the tech people, right? So, but for those who maybe aren't, they've never heard the word time series database even. Explain to them, if you can, what we're talking about.
Sure. So first of all, InfluxDB is an open source time series database. It really is the first open source time series database, and by all external measures, a leader by a big margin in the space. Mm-hmm. There are about 1.4 plus million people who run it daily, million sites run it daily, from the largest corporations down to people using it at home and that sort of stuff. Mm-hmm. And so our primary, let's call it invention or innovation, was by my partner Paul Dix, who in 2013 made the first commit. He had worked on Wall Street and had built a number of time series databases on top of other platforms, HBase, MySQL, things like that. And it turns out that there's enough difference, enough handling, enough optimizations that are available when you're working with this kind of data that it made sense for it to be one of those categorical databases, like search, like document, like graph. Mm-hmm. And so he's generally considered the person who sort of invented this space, a modern version. The first version of the product was written in Go. It had collectors, now a project called Telegraph, which is actually more popular than the database.
Really?
Yeah, there are about 400 different collectors for virtually every system out there, physical and virtual, you can imagine. And so it's a super vibrant community. We've stayed with a promiscuous MIT Apache license model, so anybody could use it.
And do, yeah.
Yeah. And if it's worth, just as a refresher for the audience, what time series is, why
what
is
do
it?
We mean, right?
Why is it? And so really it's quite simple idea, which is anytime your primary tag, anytime your primary index is going to be based on time, you can be incredibly efficient at handling large volumes at super fast, actual real-time kind of querying and ingesting and things like that. And so if you know you're going to have that kind of application, IoT, physical AI, network telemetry, where you're going to need that kind of speed, this kind of huge ingest, you start by building on the time series specific platform. So you get away from these very discrete indexes that take time. You get away from these latencies associated with queries that have to be, aggregated in different fashions. You also have to do a bunch of things you wouldn't. You have to downsample. You start with high resolution, maybe even millisecond resolution, and maybe you want to downsample to minutes. You have to evict a lot of data. So just a bunch of stuff that you would do that a normal database doesn't do. So the category has really emerged strongly. Yeah. So we're not the only player. We have good competitors. Azure offers something. Now Amazon offers us. So it's a market that's taken off. All right, that's too long. But
No, it's not too long. You know what? For people who don't know what a time series database is, that I think it's necessary. Look, for me personally, when I hear time series, I think Influx. I think because you had the open source model and the commercial offering. I know there are other time series ones, but other time series databases. But the database market isn't what the database market was when I was much younger, right? And we have graph databases and vectors and this. But when Paul Dixon did this in 2013,
he made his first commit.
He wasn't thinking about, how's this going to work with generative AI, right?
He did have, his background was in machine learning.
Really?
He wasn't completely blind to it, but no, he wasn't thinking that.
And correct me if I'm wrong, though. This is really the whole AI thing. Well, AI's helped a lot of the data collection, data storage, access. Data's a big part of it, but it's been a particular boon for time series as well, though, right? There's some real use cases.
A certain kind. So if you just sort of, you break the world into, and it's increasingly becoming apparent, you have generative AI, which is largely the scraping of the digital world.
Yep.
So anything, and now we've scraped pretty much everything that's available, and every day we scrape it again. And so there is a real shortage of digital data, images, all that sort of stuff, because most of it's been scraped in some sort of way.
Scrape clean.
And it gets indexed every day. That is not, and so the issue on the generative side is you have to create synthetic data in order to build these models to make them more sophisticated and that sort of stuff. But the opposite is true on the physical side, right? If you think about the physical world, the amount of data available to index is infinite, right? It's just a question of what resolution you want to capture it, how often you want to capture it, and that sort of stuff. And so what we're most excited about is, because of our IoT orientation, is the physical AI world. Because, the notion in physical AI, the idea is I want to get a near perfect picture of the physical world to build my models around and to act on that world, right? To build my intelligence around. And so the only way you get that is by willing to take sample measurements that are really, really
time
close.
intervals.
Yeah. So our default timestamp is nanosecond.
Really?
Yeah, and so we have some customers in quantum world who use that, but most, you're not nanoseconds.
No. But you know what? I forget his name right now. I apologize, but he was like the chief AI scientist or one of the chief guys at Meta, who just left.
Jan LeCun.
Yes.
Yeah.
And he said because we're probably coming to I don't want to say a dead end, but diminishing returns because of the problem you've outlined here, right? Which is we can't scrape. There's not much left to scrape. And that the LLM model only works, it can't imagine a sphere in open space and how it's going to fall with gravity, well, let's say.
Right.
So he calls them world models, right? Not LLMs. And they try to model the physical world.
Yeah.
And that's the kind of database, data collection, that's going to be huge.
I mean, that's what we're most excited about. And if you think about, LLMs are probabilistic models, right?
Yep.
Right, and they're brilliantly probabilistic, right? They're actually really amazing. But when you're operating in the physical world, you think of a robot, a self-driving car, a satellite in space. You need deterministic. You cannot live with probabilistic. The chance of your robot, accidentally vacuuming your cat away is just not something you
want to live with.
It's just not something you want to live with.
That's not risk I can manage.
And so the notion of deterministic versus probabilistic is important. And so collecting this data, building your models on really rich physical data, and then being able to act in a control system in a meaningful way, that's the future.
Absolutely.
So.
Hey, we could talk more about that if you want, but I got to bring us back to today if it's okay. Sure. So there is the open source. Then there's the commercial version. You guys offer like a SaaS version of it as well.
We have a couple of cloud versions,
Yep.
and we have you can run it on-prem or run it in your own instance.
And you could run it in the cloud. I know you've had a long-standing relationship with Amazon, with AWS, but you guys recently did an announcement, maybe it was a month or two ago already.
Yeah. We have credit to AWS. We have a very unique relationship with AWS. So we were always a marketplace kind of.
Yes.
You could purchase Influx. We run our own cloud services, our serverless platform on Amazon. Mm-hmm. And so we've always lived in that ecosystem. We've always worked in that ecosystem. But what's unique is about 2 years ago, they reached out to us and they were getting a lot of requests because we have all these open source InfluxDB to run Influx on their platform. And so, immediately I was like, that doesn't sound great. We're an open source player. They could just take the code.
Well, it would.
And it's not like it hadn't happened before.
I was just going to say there is a reputation there, but go ahead.
And so I was a little bit like, okay, let's build some trust here. And And the relationship we have is the first time they've ever done this is they licensed our open source code. They
Really?
run it. They run our open source code, and then we build the value-added enterprise features on top of it, and we monetize that, not in Marketplace, but in console. So when a customer configures a certain configuration, we get revenue, AWS gets. So you'd ask, why would AWS do that? You'd have to get Brad, which I'm sure you could, who runs those businesses on. But a couple of things. One is they saw the emergence of time series data, and they do have a platform, but it's a narrower use case than Influx. They were getting a lot, and so just recently they stopped taking new customers for that platform.
So they're end of life.
So their primary time series is going to be TimeStream for InfluxDB. And so in their world, that's a 1P product. It's a product, their product. It's not Influx's product. It's
just
their
based on
product
yours. They
that we
license
work
the code.
with, and we are close with them, and we work hand in glove on those deals. And we're more than happy when customers want to purchase that through that.
AWS.
That works for us. It works for them.
It's a great channel.
All that sort of stuff.
Let me stop you here for a
go ahead.
second. For my people watching this at home, if you're not in this side of the business, if you're a consumer of this, yeah, it sounds great. They got a good relationship. For people on this side of the road, though, I bet you could count those kinds of relationships with AWS on one hand.
You can't even count on one. I think we're the only one now. I think they will do more because it's worked well with us, right? Because they don't want to fork this stuff.
Yeah, you had a unique situation where, hey, they don't want to use you. Good luck. Go use what you want. You know what I mean? And there was no choice.
Right.
Influx is the bomb, as the shizzle.
Oh, I'd like to think we have that kind of market power. I don't think we do.
Oh, I'll tell you, as someone who sits here, I don't have a horse in this race.
Okay, I appreciate that.
It's kind of like secretary.
We certainly don't operate in that. We certainly don't operate with that mindset.
Don't let it go to your head. Yeah. Stay humble. Stay humble. But when I see, it's few and far between that we hear of another time series data. The hyperscalers have their in-house one, but that's the old 80-20 rule.
Yeah, it's 80-20 rule. That's
right,
exactly
80% of the function, 20% of the price.
They're good if you want to hit the easy button, and so if you decide you really want to build something.
But if you're serious about time series data,
yeah,
I get it. I guess, though, it begs the question, what about the other hyperscalers? What about some of the other providers?
Well, it's we run our serverless platform on Azure and Google, so those are available. It's likely the announcement of last week was not the original relationship. It was the introduction of our version 3 into the Amazon.
Okay.
So that happened a month and a half ago, and that's what we're most excited about. That's our canonical version now. That's where, over time, we'd love everybody to land on this version 3, which is almost a complete rewrite of.
Is it?
Of everything we've learned over the past 10 years.
Let's hear about some of the.
Yeah. So version 3.
Killer features here.
Yeah. So version 3. We just ran into a number of issues as customers scaled on our older versions. One is cardinality, and I know you're familiar with this, but maybe your listeners aren't. When you get the exponential, the number of tags and the number of descriptors exploding, it can really choke off a time series database. It's not much of a problem in observability world, but in IoT world, it's a pretty big problem because you can have tremendous variations.
Sure.
And so cardinality started to choke off on older databases on that model. Compute and storage were linked together, so that was expensive as you scaled.
Right.
Most databases are that way, but unlinking them. We didn't support native SQL before.
Really?
We supported InfluxQL, which was SQL-like, so you could use it, but like all the business applications, the other stuff that were native SQL,
pure SQL,
and the tools that were built for SQL weren't optimal. And so we ran into those problems, and so we started writing this about 4 years ago. We wrote it in the open source, and we wrote it in Rust.
Really?
The original database was in Go. We were one of the early offerings with Docker and Go, but we did it in Rust. And Paul and the team had decided that Rust was going to be a much stronger platform over the future.
More secure.
For memory safe, more secure, just a better platform for running database. So that was a rewrite in Rust. And then we built it on object storage as the native storage, so you could have long-term retention without worrying about it. And then we obviously added SQL, and then we did some really other interesting things. So we scaled it differently. We scaled it horizontally We always scaled horizontally. We just scaled it differently, so it's much easier to duplicate. And then probably most importantly, we built a processing engine directly into the database.
Right into.
Right into the database. So there are probably 6 or 7 triggers in the database that the processing engine can call, and anybody can write a Python application, script, or anything to use those triggers. So if you want to ETL stuff on the fly, if you want to transform stuff, if you want to downsample stuff, if you want to do anomaly detection, all of a sudden developers can write their own stuff and actually exercise it in real time at the same latency, the same performance that any database query would.
So this begs the question, can I set up like a Python script repo for Influx for these things?
We have one of that in GitHub, right?
Okay.
We don't have what you'd see as a traditional app store, but in GitHub we already have a repo and people are building stuff. I mean, it's pretty exciting. So the idea is that helps us move up stack. And so you want to do forecasting, you want to do anomaly detection, you build it yourself.
You want to do
hyperscaling, have to buy third-party
right? In today's world, it's all about scale. So you took a 2013 database and brought it into 2025.
Painfully. Just want to say painfully.
Well, if no pain, no gain.
Well, it turns out, one of the things, I came from the networking and security world, not necessarily from the database world when I started here. One of the things you realize is you cannot accelerate the time it takes to mature a database.
No.
You can't just say I'm going to have a database built in a year and think that it's going to be able to scale. You're not going to have gigantic issues. It has to run in the real world. So in some ways, now that you look at AI, we're kind of the boring part of that infrastructure, which is fine, but we're the least disruptible part of that infrastructure.
Right, and it's nuts and bolts kind of stuff. Unique thing here, though, is you have the open source. How big a help was the community in this kind of relaunch?
There are places where the community
I don't want to call it a relaunch, Evan. That's a bad word.
Thanks. Just
in
the
this
version,
next
next generation version. The community is super helpful in certain areas. It's really hard for the community to be really helpful in the database. But here's the distinction. We built this based on a bunch of Apache standards, some of which we're the main committers. So Apache Data Fusion and Apache Arrow, the memory format. So we now commit to those, and we use that in it. So we took advantage of the community. And then Data Fusion, that's a project where we're the PMC. It's a super popular. It competes with the query planners and engines that are in Databricks and in Apple's Proton and things like that. And so that's a big project. So we leverage those. And then we're really also leveraged on the connectors. Our community's constantly writing these Telegraph plugins.
And that's the bread and butter here, man.
You got to be connected.
Yeah.
And you got to be connected without ETL, right? And you can do that in time series.
What about MCP servers, stuff like that?
Yeah. So we
check.
Yeah, sort of check. 4 months ago, we're now using it in version 3 so that people can do natural language queries directly against a database without knowing SQL or that sort of stuff. Some customers are using it. I think it's really important. It's not driving our business today. Yeah, but it's really important.
It is. So I got to imagine with this deal with Amazon and version 3 out here, it must be attracting a decent amount of buzz at the show.
It's this show is
crazy. I know, but it is 60,000
basically. People. This show is I don't know what was a decent buzz at the show. Well, their keynotes are what casual buzz at the show, but no, it's in general. We're just in a really good time in the business. Having the database out, having the level of maturity that we finally need, Amazon coming in, it just feels like a bunch of forces are working. The narrative now in the community is really much stronger around physical AI, and people are paying a lot of attention to that kind of work. And so, but this event, it's, I don't know if you were at the keynote, but I talked to people who were. It's like everything was about agentic AI.
It was all agentic AI.
Database stuff and all the infrastructure, all the cloud stuff.
They didn't talk about data at all. Forget database.
Yeah.
They didn't even talk about data. Used to come to this show. They talk about S3 and Lambda and serverless.
Yeah.
It's still there if you dig deep enough, right?
Not in the main keynote.
Not in the keynote.
And I get why. No, I understand.
So we've spoken about this on our shows. Look, I personally think they they can go head to toe to toe with Google and Microsoft on AI, because Google has a good AI stack.
100%.
Right?
100%.
The training and
And-
processors, all these things.
And for the last 10 years, the narrative is about cloud computing. And so, and that, cloud computing
They
is
don't
default
even
now.
mention- right?
Right,
They don't
it's
even
default.
mention cloud here.
Yeah.
It's all. You're right. It is all AI. I had a question in my mind, and I got stuck on this thing with you right here. But I'm sure it'll come back to me in a second. But let me ask you. Actually, I do remember it. You mentioned graph databases before. That's huge, bigger than it's ever been,
Yep,
right?
yep.
And the other thing, what's driving a lot of this data is this whole observability space. I mean, it's hard because AI sucks the oxygen out of every conversation we have. But you look at like observability, you look at the growth in graph databases. I've spoken to a lot of end user organizations where they're using a time series database. They're also using graph. They're also using SQL. Right? It's not a one database town no more.
No, no. In fact, my take on this, and you and I are of a similar vintage, is, when we were growing up in the industry, at least in the early years, there were only two databases that mattered.
Yeah.
There was, Oracle and IBM
yeah.
DB2, and
Yep.
so you just choose which one. And then we saw the emergence of MySQL and the open source, and that stuff probably started, 18 years ago or so. And then you saw the taxonomy of dropping into these specialty databases,
Right, the
document,
NoSQL
search,
and all of the
NoSQL, graph, and
Yeah.
all of that. And now those are pretty well-defined categories with large competitors. And so, really, and the ability to assemble the appropriate data models and do it are important. But I think the important thing is the Oracle and IBM of this world that I foresee, are the Databricks and the Snowflakes, and now
Yeah.
the Fabrics and the BigQueries and
They are.
those are the databases, right?
Yeah.
We are all live in that constellation. Our data, if done right, the models are built somewhere in Databricks or Snowflake, right?
Yeah.
They're all the structured data, the unstructured data, it's all combined. The intelligence is built there, and we view ourselves, and this is distinct. And most people don't dive in, not as an analytical database, even though our analytics are great. We view ourselves as an operational database.
Really?
Yeah, we want people to build control systems. We want to build, dashboard list monitoring systems. We want to build automation. We want people to use our stuff
And
to
integrated
be
into
active.
the right.
Right? We don't.
Because it's
the
part of
analytics
this
are there.
thing.
Yeah.
No, I get it. I mean,
You have to be.
it's table stakes.
Yeah.
But I never thought of it that way. That's actually a good.
So you think about our customers, whether it's Tesla trading energy from the power walls, whether it's Eutelsat or Kuiper are doing, the early satellite positioning and the change of positioning. Like, these are all things that are happening in somewhat real time. These are things that lakehouses can't do,
No.
right? Their latency, the orientation, the cloud only. Half of our customers are 3-tier architectures where they have stuff on-prem and in the cloud. It's a totally different, it's a very different world.
Thing. It's this whole the data, the age of the data scientists, right? And this AI thing is giving them rocket fuel.
Yeah, yeah.
Right? Data scientists reign supreme. We see it even we have the newest site we launched is platformengineering.com. So we're very big in platform, right?
Yeah.
The biggest element joining that community, data scientists. It don't make sense to me at some level, but data scientists are very interested in making sure they have this platform.
So this is you say it that way. So what we see going on, and it's early, is that there's an emerging category called that feeds the data scientists, that feed these data engineers.
Yes.
Right? Literally, they're not SREs, they're not DevOps.
No, SREs are
they're
distinct
nothing,
group.
right? These are people who build these pipelines. So you have these distinct databases, you have these flows. They own the engineering. They're like, if you think of it, we used to talk about plumbing.
They own the
They
platform.
are the real plumbing.
Right, they own the
are.
platform.
How does the data move across these applications? How are they made available to the model? How do they operate in real time? That, if I could train, I have 2 college-age kids, if I could train them to do a job that I thought
That's
would be
the job.
future-proof,
That might be it.
that would be the
And I
kind of
think
stuff.
that, look, So we own platformengineering.com. My friend Luca Galante runs platformengineering.org. 300,000 strong community. And I'm telling you, those are the two fastest growing elements in that community is data engineers and data scientists.
Yeah.
Because that's where the action is, at least right now anyway, and going forward. It's interesting.
No, it's in the way we, in the late 90s, the network engineers.
Right, remember?
Remember how important those roles were? They still are obviously incredibly important.
That's how I got into computers, playing with WordPerfect and Novell.
Novell. You're doing your IPX LAN.
Yeah, remember? Don't ask. Anyway, Evan, it's been great catching up with you. We got to give some call to action. You know
All right.
what?
Okay.
A good marketing person I had here earlier said you always got to end with a call to action.
So the call to action is if folks are interested in anything, any resource associated with building, our role is to make it super easy for developers to start with time series. The database is super easy to use, download, available on GitHub on our site, and feel free to visit us at www.influxdata.com or do your local ChatGPT search and see how we're doing on Geo.
How are you doing on
I think
Geo?
we're doing pretty well.
I got a note today that a customer told one of our people, we found you, we did a search on ChatGPT for DevOps and SRE.
And you guys
And
came up.
they sent them to, yeah. That was
Yeah,
pretty
it's
cool.
the world. That world has changed. You could do a whole show on
That's
that.
a whole, we do. Anyway, my friend,
It's great seeing
good
you.
to see you.
All right, thanks for
Evan
having me.
Kaplan, he's
Thanks,
one of a
and
kind,
thanks Sousa folks for sponsoring this.
man. Absolutely. Well, as a matter of fact, we have more Sousa coming up later today, so stay tuned for that.